Hello everybody and welcome to exercise 2b. This is another example of finding an antiderivative using a u substitution. So we're going to take this integral that they're giving us, try to make a u substitution to transform it into an integral that we can actually do easily. Okay, we'll use the same idea that we did in the problem above. We want to make a choice for a u. Kind of a natural choice in this case is to take the function that's underneath the square root. Okay, so we're going to let u be 1 plus 3 cosine of theta. Okay, and once we've made that choice for u, first step is to go ahead and take the derivative of that u. So derivative of 1 plus 3 cosine of theta, the 1's going to go away, and 3 cosine of theta, the derivative of that is just negative 3 sine of theta. Tack on a d theta at the end. Okay, and then we'll try to get the d theta by itself. So divide both sides by, not negative 3 cosine, negative 3 sine. Okay, to get the d theta by itself. All right, and the goal now is to go ahead and see if we can rewrite this integral. So let's see what we've got here. Start with the sine of theta. The part under the square root we called u, so we'll write the square root of u. And then d theta, this part at the end, we can see from our work that d theta is equal to du over negative 3 sine of theta. Okay, so there's where we're at so far. And notice that we get some cancellation here. Sine theta in the numerator and the denominator, those go away. And that cancellation is generally a good sign when you do a u substitution. We want things to cancel. Okay, so looking at what we've got, this negative 3 is a constant, so we can pull that outside of the integral. It's in the denominator, so it's going to come out as a 1 over negative 3. And then what's left in the integral is the square root of u du. And notice that so far we've taken the integral that we started with, which was pretty complicated, and transformed it into the much easier integral that looks like the integral of the square root of u du. All right, so we need an antiderivative for the function square root of u. And there we might remember that the square root of u is really just u to the 1/2. So we can use the ordinary power rule to do that integral. Okay, so we'll take that u to the 1/2. We're going to raise the 1/2 power by 1. 1/2 plus 1 is 3/2, and divide by the new power. Okay, plus c because it's an indefinite integral. And then we can do a little simplifying. So we've got negative 1/3. We're dividing by 3/2, which is the same as multiplying by 2/3. Okay, and so let's see if we take those two fractions and multiply them together, we're just going to get negative 2/9. And u, we know what u is equal to, so it would be nice to write our answer in terms of theta, because that was the variable that we started with. So we'll just resubstitute the u again. We can look up in our work and see that u is 1 plus 3 cosine of theta. So let's go ahead and just substitute that back in. Okay, and there is our antiderivative.